Okay, so we're going to be doing LRAM now. Okay, so I've got a cubic function. I'm going to find the area under the cubic function from -1 to 2 using 6 intervals. Okay, since my distance is 3 and I'm using 6 intervals, again, the width of each one of my rectangles is going to be 0.5. This time I'm starting at -1. The best thing to do is to start by drawing my parent function. So I'm going to mark off my y's by 10. So this is 10, 20, 30, 40, 50, 60. And then these are still going to be 1. So this is -1, 0, 2, 3, 4. Okay. So when we start off, okay, at -1, so when you plug -1 in, you get 0. So our parent function's 0. At 0, we're at 2, so somewhere like right there. Then at 1, we're at like 4, so it's really close to there. And then at 2, we're going to be at 18, which is almost 20, so that puts it somewhere like that. And then at 3, we're going to be at like 56, so somewhere like right there. So this kind of gives us an idea of what our function looks like. So this one goes like that, and this goes up like this. So there's basically what my cubic function looks like. Okay, so let's draw in a rectangle. So our rectangle is starting here at -1. They're ending at 2. And these marks represent how many? So that's 1, 2, 3, 4, 5, 6. Okay, we're doing LRAM. Okay, so the heights of these are going to be based on the function, or the rectangle's hitting it on the left side. Well, on the left side here, we're at 0. Here it'll hit it there. This one will hit it here. This one will hit it here. Then here. Then there. So these rectangles basically represent our function, okay, our area. Now you can see that this is not going to be a very good approximation because there's a lot of missing area here, okay, but there's not much we can do about that. That's what they're asking us to do. So when I start my chart, I'm going to start, my first one's going to be at -1, then -1/2, 0, 1/2, 1, and then 1.5. Okay, since that's all of the rectangles I have. I only have 6 this time. Okay, so then again, we plug these values into our function. So we're plugging it into f of x. So like f of -1 equals 2 times -1 cubed plus 2, which gives us 0. And then you plug in -1/2, and you get 1.75. Plug in 0, you get 2. Then 2.25, 4, and 8.75. Okay, so these are the heights of all my rectangles. And again, I keep telling you guys these are just the heights. Now, if you wanted to, if you don't like the way I do it where you add up the heights first, you could sit here and multiply every single one of these by 0.5 and get the area for each individual rectangle if you would like. And then add up the total areas. I just don't like doing it that way. If the rectangles, the widths weren't constant, if they weren't all 0.5, we'd have to do that. But since they're not, we don't have to. Okay, so when you add up all of these, all 6 of the heights, that's your total height. Again, your area is your total height times the width, which is 18.75 times 0.5, which means my area is 9.375. Okay, and like I said, this area is not a great approximation. We're missing, you could see, all of this right here, all of that right there, all of that right there, and your actual area under the curve is actually 13.5. So you can see this isn't a very good approximation. Again, if we wanted to get our approximation better, we could either create more rectangles. We could do 12 rectangles, and that would fill in some of that, or we could do MRAM. That would be a lot better. Changing to RRAM wouldn't really help. That would just be an over approximation. Okay, so just make sure that when you're doing these that you're starting off on the correct number. So for instance, if we had started off at -1/2, -1/2 instead of -1, that would have been like doing RRAM. So make sure you're starting at the right point and ending at the right point.